A parallelepiped looks like it's a three-dimensional prism that's kind of been tilted one way. It's not necessarily a right prism. So how do we find the volume of a parallelepiped? Well, the three sides of the parallelepiped will be defined by vectors. And to find the volume, all we have to do is pick any two vectors and cross them, and then dot them with the third. Now, the only problem is sometimes you get a negative answer. So the only thing I ask is that you report your answer as positive. So let's take the absolute value of that. No matter what I do, if I do U cross V and then dot it with W, absolute value, or if I take V cross W and then dot that answer with U, or if I take U cross W and then dot it with V, and then take the absolute value at the end to make sure my answer is positive, it doesn't matter. I'll end up with the volume of the parallelepiped. So in short, take any two vectors of the parallelepiped, cross them, find that vector answer, and then dot that vector with the third vector, and you'll get a scalar number. The positive of that scalar number will represent the volume of this shape. For example, if I chose the first way that I happen to pick, U cross V dot W, the first thing I want to do is work inside the parentheses. Find U cross V. That means U goes in the second row, V goes in the third row. I write out my three matrices. I find the discriminant of those three matrices by taking my down products minus my up, down minus up, down minus up, my products, my product, my products. Don't forget to subtract this. Ultimately, I'll get 8i plus 6j, plus 6k, which is 866. That is this part of the answer. Now, what I want to do is dot that with the third vector, 3, 1, 1. 3, 1, 1. Remember, when you're taking the dot product, it's x component times x component. So that's 8 times 3 plus y component times y component plus z component times z component, to give us 24 plus 6 is 36 units cubed. Now, this came out positive, but I would want to take the absolute value of that to report my answer as positive always. It wouldn't matter which way I had chosen. If I just grabbed U and W and crossed them and then dotted with V, I still would have gotten, with my absolute value, 36 units cubed. A second way to find the volume of a parallelepiped is to use the determinant of a 3 by 3 matrix. Our order, again, doesn't matter. I happen to write U, V, W. So I can write a 3 by 3 matrix as 3, negative 5, 1, 0, 2, negative 2, 3, 1, 1. Now, it just doesn't matter that I went U, V, W. There's no magic to that. What I will do, however, to find the determinant of this 3 by 3 matrix is write column 1 over again, 3, 0, 3, and then I'll write column 2 over again, negative 5, 2, 1. Now, remember, to find the determinant of a 3 by 3 matrix, first I'm going to multiply down and find each product and add them. So 3 times 2 times 1 is 6, plus 5 times negative 2 is 10 times 3 is 30, plus 1 times 0 is 0. I'll call those my down products. I go down, 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 down. I have the sum of the down products. So here is the sum of down products. I will now subtract the sum of the up products. So the up products will be this way, 3 times 2 times 1, 3 times 2 is 6 times 1 is 6, 1, now I'm going up again, 1 times negative 2 times 3 is negative 6, and lastly, I'll go up this way, 1 times 0 times 5 is 0. So this here is the sum of the up products. And you can see that this will be 36 minus 0 gives us 36 units cubed. And if that ever came out negative, just take the absolute value.